We think of the modern world as weightless. Cloud computing, wireless data, silent green energy grids, it all feels as though it exists suspended in the air. But beneath the surface of every wireless router and every massive server farm lies thousands of tons of a heavy physical element. The digital age is entirely tethered to the ground. The reason lies in atomic structure. Copper has a single free electron in its outermost shell. When exposed to a voltage difference, that electron flows almost completely unobstructed, making it nature's ultimate physical conduit for energy and information. We realized this long before the internet. When the first global telegraph networks wired the world together in the 19th century, they relied on this exact atomic quirk to carry electrical signals across oceans and continents. Despite our obsession with invisible digital advancements, our entire civilization remains strictly bound to the physical limits of this ancient metal. The atoms making up those cables are billions of years old. They were forged inside the extreme heat and pressure of collapsing supernovas, then blasted across the universe in massive cosmic explosions. When the Earth formed 4.5 billion years ago, a small fraction of that stellar dust became trapped. Today, it sits deep within the planet's crust as microscopic flecks, making up just 0.5% of the surrounding rock. Early humans found rare, pure nuggets of it on the surface. When they eventually combined it with tin to create bronze, human civilizations gained the ability to forge heavy armor and highly durable agricultural tools. Today, those surface nuggets are gone. To gather enough material for a single electric vehicle, engineers detonate and excavate hundreds of tons of solid rock just to extract a single ton of the metal. Building the clean, quiet future we envision requires executing the most massive, violent earth-moving operations in human history, all to isolate this specific atom. The extracted rock is immediately crushed. Massive steel ball mills grind boulders down into a fine powder to physically expose the trapped copper particles. In massive vats of water and chemicals, air is injected. Because copper sulfide particles are naturally hydrophobic, they avoid the water, clinging to air bubbles and riding them to the surface to form a metallic foam. This concentrated foam still contains iron and sulfur, locked in tight chemical bonds with the copper atoms. Breaking those bonds requires extreme heat. Inside a flash furnace, the concentrate is exposed to temperatures exceeding 1200 degrees Celsius. Engineers blast oxygen directly through the molten liquid, chemically reacting with the iron and sulfur and burning them away as slag and gas. Acquiring industrial-grade metal is an exercise in physical and thermal violence, stripping away useless rock to force a chaotic element into a highly concentrated form. The smelting process yields metal that is 99% pure. For structural uses, that is sufficient. But for electrical transmission, that remaining 1% of impurities creates physical resistance, causing the metal to heat up and lose energy. To solve this, the blister copper is cast into heavy plates and submerged into massive vats of sulfuric acid. When an electrical current is applied, copper atoms lose electrons, dissolving into the acid as ions and migrating to physically rebuild on a cathode sheet. This strict physical requirement for zero electrical resistance traces back to early electromagnetic pioneers like Michael Faraday, whose experiments proved that moving power over distances required flawless conductors. By achieving 99.99% atomic purity through this slow chemical bath, we create the exact physical conditions necessary for the modern electrical grid to handle massive voltage without burning itself to the ground. These pure cathode sheets are melted and pushed through diamond dies under immense pressure. The metal is extruded into various profiles, from heavy transmission bus bars down to hair-thin wires. In the transition to green energy, those wires are heavily concentrated inside electric vehicle motors. Thousands of feet of high-purity wire are densely wound into the stationary core of the engine to handle massive electrical currents. When alternating current flows through that low-resistance winding, the migrating electrons generate a powerful magnetic field. That invisible field physically pushes against the motor's rotor, directly converting electrical energy into mechanical torque. Beyond Earth, this metal manages extreme thermal shocks and shields sensitive electronics from cosmic radiation, serving as the physical lifeline for deep space exploration. Copper operates as an active physical engine, translating raw energy directly into the motion that drives our most advanced technologies. Unlike carbon fuels that burn and vanish, copper possesses a unique ecological advantage. It is fully 100% recyclable. It can be melted down endlessly without ever losing its atomic integrity or electrical efficiency. Because of this, modern cities function as urban mines. Aging infrastructure, stripped wiring, and discarded electronics provide a massive, easily accessible reserve of the metal. This scrap is continuously harvested, shredded, and fed into furnaces. Today, a third of global demand is met by resurrecting old material into brand new infrastructure. Because it connects housing, technology, and transportation grids, financial markets carefully track the global demand for this endlessly circulating metal to diagnose the health of the world economy, earning it the nickname Dr. Copper. Forged in dying stars, violently ripped from the earth, and endlessly recycled through human cities, it remains the permanent, unbreakable bedrock of human civilization.